You hit a golf ball at an angle of 25 degrees and watch as it hits the green 100 meters away. Given that the green is at the same height from where you hit the ball, how fast did you hit the ball? All right, so in this problem, it's going to be a little bit more challenging, just math-wise. The setup is actually very, very easy, but then solving the math can get a little bit tricky. So we'll hopefully follow along. Bear with me. We have the picture. Here's a little golfer going to hit the ball at that angle. The velocity is the hypotenuse. That's what we're actually trying to find. We don't know how fast the ball gets hit, which means we can't actually solve for the velocity in the x or the velocity in the y at the beginning of the problem. We can set it up. We can say how we would do the right triangle problem. But since we don't have the hypotenuse, we only have the angle, we wouldn't actually be able to solve for that the pieces of the velocity x and velocity y, at the beginning of the problem. We do know that the distance in the x is 100 meters. So I'm going to write some numbers down that we have from our problem. The displacement is 100 meters. And because the velocity in the x is the adjacent side, I would still find that using cosine. So I'm going to write that down. Even though I can't actually plug it into my calculator and get an answer yet, it's still a helpful piece of information. So the velocity in the x direction is still the cosine of 25 degrees times the actual velocity. I'm going to write the actual velocity, how about in blue, because it's the thing that we are trying to find in this problem. So that way we can make sure we know where it is at all times. In the green, the up and down, I know my displacement is going to be 0 because it's going to land at the same height that it was hit from. My initial velocity, I don't know what it is, but I know that if I was trying to find it, I would use the sine of the angle times the velocity, which is, again, what we're trying to get. Finishing this up in the y direction, we know the acceleration is negative 9.8 meters per second squared. Now, we still only have one equation in the x direction to pick from. So I'm going to write that down. Displacement equals velocity multiplied by time. I'm actually going to take this, I'm going to plug this velocity in here, what we have for velocity, the cosine of the angle times the velocity, in here, and you'll see why in just a minute. It will help us make a little bit of sense. The displacement is going to equal the cosine of 25 multiplied by the actual velocity we're looking for, multiplied by t, which is a number we do not have yet. I'm going to rearrange this equation for t. Why? Because I actually do have the d is 100. So I'm just going to arrange this for the thing that I don't have, because what we're ultimately going to end up with here is a simultaneous equation. If I write down my equation in the y direction, I'll do that first so you can sort of see where we're going. We would be using d equals v naught t plus 1/2 at squared. But much like in the red, we don't have v naught. So I'm going to actually plug in the sine of 25v here. So d equals the sine of 25 multiplied by the velocity we're ultimately trying to find. That's going to be multiplied by t. So I just finished that term. I expanded the v naught with the sine of 25, v times t, plus 1/2 at squared. We have the d in the y direction. We know it's 0. We do not know the time. We do not know the velocity that we're trying to find. And we know the a is negative 9.8. So we have two variables we don't know here. That would be time and velocity. We have two variables we don't know here. Again, time and velocity. So we have a simultaneous equation. It's just kind of a big simultaneous equation because we're going to have some sines and cosines in it. It'll simplify out. It'll hopefully make a little bit more sense as we go. So I'm going to rearrange this for time so that I can take time equals some stuff here in the x and plug it in over here in the y. And then that's when the algebra kind of starts and the physics is completely over. So rearranging this for time, I would get the displacement divided by the cosine of 25 degrees times v, and that's going to equal my time. And since the time is the same in both, I can take this and plug it in here and plug it in here. And when I do that and I expand my equation, bear with me while I'm writing it. I'm going to try to keep it in multiple colors, at least for the first time I write it here, so it's kind of easy to see where this stuff is going. My y equation, I'll even plug the 0 in here, hopefully make my life a little bit easier. I'll write it up here, hopefully give myself a little bit more space. I would have 0 equals, that's going to stay, sine of 25 times v. So my sine of 25 times v hasn't changed. And now I'm going to plug in the d over cosine 25v where time was. That's going to give me the d in the x over cosine 25 degrees times v. So that's this first term when I plugged in d over cosine 25v here for t. Now I'm going to add this term, the 1/2 at squared. So the 1/2 a hasn't changed. And now t, again, is this. I've got to square everything that's in there. Which means the d is going to get squared. And in the denominator, I have cosine squared 25 times the v, which also gets squared. This may look a little bit nasty, but we actually have pretty much everything in here. Sine of 25 and cosine 25, we can plug that into a calculator. V and v is actually what we're trying to find. D in the x is 100. A is negative 9.8. D, that's again in the x. Make sure that we know that. That's again 100. And that just leaves us with v. I'm going to simplify this up a little bit so it doesn't look quite so nasty. Sine 25 over cosine 25 is actually tangent of 25. And v over v cancels, which means that one goes away, leaving me with just d in the x direction. So that's not quite so ugly now. When I get to this side over here, that one's going to kind of stay as it is, 1/2 a d in the x squared over cosine squared 25 times v squared. Now, I don't normally plug numbers in right away, but in this case I'm going to because it might make your life a little bit easier and this won't look quite so scary. So here's what it's going to look like if I plug some numbers in right away. So here's 0 equals tangent of 25 degrees. D in the x is 100 meters plus, I'm going to do this fraction, 1/2, a is negative 9.8 meters per second squared, and d in the x would be 100 meters. That also gets squared. Make sure you don't lose your squareds here. You're going to get some very weird answers. Divided by the cosine squared 25 times v squared. I'm now going to plug this stuff into my calculator. Tangent 25 times 100, 1/2 times negative 9.8 times 100 squared, and I can even plug in cosine of 25 and square that. When I do that, I plug all that into my calculator. What I'm going to get is 0 equals the tangent of 25 times 100 is 46.63 meters, stays as my unit, plus 1/2 times negative 9.8 times 100 squared is going to get me negative 49,000. My units here, I'll keep the meters per second squared, and then that's going to become meters squared. So it's actually going to be meters cubed per second squared. And that's going to be divided by this cosine squared 25. And when I plug that into my calculator, I get 0.82. And then I've got the thing that I'm still trying to find, which is v squared. This now doesn't look nearly as scary as it was looking up there, hopefully for you. Now we're just going to do a little bit of algebra to solve for v squared. First thing I'm going to do is I'm going to subtract this 46.63 over to the left. So we get negative 46.63 meters equals negative 49,000 meters cubed per second squared, all over 0.82, and v squared. I'm going to multiply v squared up over here to the left. So we get v squared times negative 46.63 meters. That's going to equal negative 49,000 meters cubed per second squared, all over 0.82. Now I'm almost done. I can just divide this negative 46 over here. I'm going to do the square root, and that'll get me v all by itself. So my numerator stays the same, negative 49,000 meters cubed per second squared. I'm going to divide this guy over. So I'd have 0.82 times negative 46.63 meters. And again, I don't want the squared here, so I have to do the square root of this right side. And now we just have to plug into our calculator, and we are completely done. And when we do, we would get that the velocity equals 35.8 meters per second.